Okay, so part two of the project, I'm actually going to go explain what happened with what I experimented on. So here's a free body diagram. This won't obey the third law because that'll be a bit tricky to draw, and I don't really want to draw it. I'm using a ruler here to pretend like I'm actually using it, but as you can see, it looks very terrible. So this first box here, it's gonna be representing the tray. So we're gonna put an approximate mass of it at 0.2 kilograms. Now my bag is gonna be having a mass of, let's go with 1.5 kilograms. Ignore the inconsistencies between the decimal and the improper fraction. So here is a proportional arrow to show how much force was used to push these objects respectively in that distance. So, seeing as I don't have access to equipment that can actually calculate the force properly, we're just going to give up some random numbers. So, the first force will be 5 newtons, and the second will be 1, 2, 3, 4, 20 newtons. Now, because of Newton's second law, force is equivalent to mass multiplied by acceleration. Now, in our experiment, we kept acceleration as a constant. So here, I'm going to put acceleration as 2 meters per second squared. Now, I said it was going to be close to 0, and if we were to take a number like 1 times 10 to the 30, it is pretty close to 0, comparatively, right? So, mass, we came up with these masses. We came up 200 grams, is it? 200 grams, and 1,500 grams, respectively. Okay, so my phone fell off my stand. So we are back at this. Each of these are respectively 200 grams and 1,500 grams. So as we can see, the force required is actually proportional to the mass multiplied by the acceleration. So let's actually do the math right now to find a somewhat still about the same accuracy because these numbers were still made up. So force of tray, the force required for the tray will be 0.2 times 2, which should give us 0.4 newtons. Fairly close. And force required for bag, F of bag, would be 1.5 multiplied by 2. Okay, so that's 3 newtons. So, as we can see from here, there is a relationship because force and mass here, they are directly proportional to each other, shown by this experiment. And if I were to change up the acceleration by using the same force as in this free body diagram, okay, and they have the same force and still the different masses, we would see that acceleration would be very different. Alright, that's it.